Hi, Assalamualaikum and good day. So this is a lecture for ASC0304 subject Chemistry 1. This is for chapter 1. The title is Chemistry, Matter and Measurement. The first thing is you are going to look into the learning outcomes of this topic. First, to classify samples of matter as pure substances, homogeneous mixture, heterogeneous mixture, substance, compounds, elements, atoms and molecules. Number 2, to recognize the various forms of matters, changes of matter and properties of matter. Number 3, to apply appropriate units to describe the result of measurement. Number 4, to use metric prefixes and conversion factors in chemical calculation, which are kilo, deci, centi, milli, micro and nano. Number 5, to explain the difference between precision and accuracy and uncertainty. Number 6, to express numbers in scientific notation. And the last one is to apply the concept of significant figures in chemical calculation. So the first thing is matter. It is anything that has mass and occupies space and can generally be perceived by our sense. For example, as color, texture, odor, hardness, and also taste. It includes everything around us, including the air that we breathe, our skin and bones, and the earth underneath us. So matter can exist in 3 different states, which are gas, liquid, and also solid. So if you look into this figure, this is to show the states of matter because they depends on the temperature. That's why matter can exist in 3 different states. So if we start from here, at higher temperature, matter can exist in the form of gas. So when gas is cool or compressed, it can form liquid. And whenever it is cool, it can form crystalline solid, meaning that the solid can exist at lower temperature. Similarly, we can also transform crystalline solid into liquid by heating the solid so it forms liquid, and then from the liquid we can apply heat or reduce the pressure to form gas. Now the classification of matter. First, pure substance, which are elements and compounds, and also mixtures, which are heterogeneous and also homogeneous mixture. Let's look into substance. So since matter can be classified as pure substance and mixture, substance is a matter that has a definite composition and do not vary from one sample to another. All substances have mass and therefore must be composed of atoms. These atoms and how they assemble themselves in the substance determines their chemical and physical properties. Let's look into the example. This is the example of substance. The first one is water. The formula is H2O. So the composition of water is 2 atoms of hydrogen and 1 atom of oxygen. So as you know, the properties of water, it is clear, colorless, homogeneous liquid that is good for human consumption. And the second substance, for example, here is hydrogen peroxide. So the formula is H2O2. The composition of hydrogen peroxide are 2 atoms of hydrogen and 2 atoms of oxygen. So the properties of hydrogen peroxide, it is clear, colorless, homogeneous liquid that is considered harmful if consumed by human, and also it is considered as poisonous. So as what you can see, different composition of substance form different, totally a different characteristic of the product. Okay, substances can be classified according to how these atoms are assembled and is known as classification of matter. All matter falls into one of 3 categories: elements, compounds, or mixtures. An element is a substance made up of atoms of one kind. Element is matter that cannot be broken down into simpler substance by chemical reaction. The example of monoatomic elements, helium, aurum, or sodium. Diatomic elements here, meaning that it consists of two atoms, oxygen, hydrogen, and also chlorine. And if we look into more complex element, for example, here is O3, S4, or P8. Compound is made up of two or more elements chemically bonded in definite proportions and can be broken down into simpler substance. Example is salt, NaCl, sodium chloride, water, or sucrose. So this is the difference between elements and compound. Now let's look into mixture. A mixture contains two or more different components in varying proportions. So, as what you have seen in learning outcomes, it can be classified into homogeneous and heterogeneous. This is the example of homogeneous mixture, in which it has the same composition throughout a sample of matter. Components are indistinguishable. Example, alloy, just like the figure here, air or salt water. Let's look into heterogeneous mixture, in which it varies in composition from one part of the mixture to another. This is the figure that shows the example of mixture. Such components are distinguishable. The example of heterogeneous mixture are mixture of salt and charcoal or mixture of oil and water. As what you can see here, the rock here, it is distinguishable, meaning that it is a heterogeneous mixture. Matter can be described by its physical or chemical properties. Let's look into physical properties. It is displayed by a sample of matter without undergoing any change in its composition. This includes mass, color, temperature, volume, density, melting point, and etc. Meanwhile, chemical property is displayed by a sample of matter as it undergoes a change in its composition. This includes flammability, toxicity, reactivity, acidity, corrosiveness, and etc. Now let's look deeper into physical change. It is a change in which the substance changes form but keeps its same chemical composition. For example, when evaporation, melting, frozen, dissolution, or crystallization occurs. For example, if you heat an iron bar until it glows red hot, it is still chemically the same iron. The iron has not changed into something else. The second example is, if you dissolve salt in water, you have not changed the materials chemically. You still have salt and you still have water. This can be shown if we choose to separate the mixture by the simple evaporation of the water. The salt would be the residue and the water would be the distillate. More example of physical changes is here as well. When ice is melted and the liquid is then evaporated, all three forms of water are chemically the same, which is H2O. For either process, there is no change in the identity of the substances. So this is true for all physical changes. So this figure shows how water molecules change from liquid to gaseous state, meaning that it changes physically. When water boils, its chemical composition remains the same. The molecules are now further apart, meaning that they are still water. The difference is this H2O in liquid form and this H2O in gas form. Now, let's look into chemical properties. This description of how a substance reacts chemically. Example, the rusting of iron in the presence of air and water, or the souring of milk, or the burning of pepper to form carbon dioxide and water vapor. Chemical change is change in which something new is formed which this process is irreversible. The starting materials change into an entirely different substance or substances. This new substance has a different chemical composition than the starting material. Certain observation will indicate that a chemical change has occurred. For example, the reaction produces a change in temperature, formation of gas bubble, formation of a precipitate, change in color, formation of a different order. Example, corrosion of metals, polymerization of alkenes, or fermentation of foods. So during a chemical change, atoms rearrange the way they are attached to each other, forming new substances with properties that are often quite different from the starting materials. For example, propane gas burning, as shown in this figure. So this material starts from a propane, react with oxygen. So this reaction produces carbon dioxide and also water, meaning that chemical composition altered. This is what is known as chemical change. This is also a chemical reaction in which propane molecule change into carbon dioxide and water molecule. So we will continue the second part of this lecture with atom topic. Thank you.